So 3 matching side lengths. 3, 4, 5, 3, 4, 5. Yes, they are because they have the same side
These
lengths.
triangles are identical.
Are these ones identical? So you have to check that. Oof. And no, because they wouldn't have the same side lengths.
These triangles are not identical.
Same angles, but not same side lengths.
When triangles have the same 3 angle measures, there are many triangles you can make. They are scaled copies of each other, but not necessarily identical. So we know when triangles have 3 matching sides, all the triangles are identical. In other words, there is one unique triangle you can make with those conditions. And when there are 3 matching angles, not all triangles are identical, so there are many triangles you could make. Let's look at some other triangles with different conditions. What if triangles share 2 side lengths and 1 angle measure? Will you always get identical triangles? Start by checking to see if these are identical.
Nope. Oh. Maybe I just didn't click the right buttons.
These 2 identical triangles share a side, then an equal angle, and then another side. They match up perfectly. Let's change this triangle a little. I'll adjust this triangle so that the side length of 6 units is over here. These 2 triangles still share 2 side lengths and 1 angle measure. But this time, the angle is not in between the 2 side lengths we know. It's only next to the 4 unit side. Are they identical?
No.
This time, they are not identical. No matter how you flip, turn,
No, because the side lengths are in different spots.
we looked at 3 triangles that had the same 2 side lengths and 1 angle measure as our original triangle, but only one was identical to it. Notice that the triangle that was identical had the angle in the same position. It was in between the 2 side lengths we knew. The other 2 triangles had the same angle, but it was in a different position. There are different triangles you can make with the same 2 sides and 1 angle, and the triangles are identical when they have the 3 common measures in the same order. Now let's think about some triangles with 3 other common measures. What if they have 1 side length and 2 angle measures in common? Will you always get identical triangles? Start by checking to see if these are identical.
I think no.
These are not identical.
So these 2 triangles, 2 angles, and 1 side in common. So is that the button I clicked last time? And these ones are, and yes, enter.
These are identical. Notice the side length we knew was in between the 2 angles we knew in both triangles. Let's change this triangle again. Are these 2 triangles identical?
Oops. it made it a different size.
We looked at 3 triangles that had the same 2 angle measures and 1 side length as our original triangle, but only one was identical to it. Notice that the original and the identical triangle had the common side and angles in the same position. The common side length was between the 2 known angles. The other...
That's pretty much all you need from there. And then we're going to go
Keep it going in the Tower of Power.
In the Tower of Power. Okay. Tower of Power. Alright, are these triangles identical? So these ones have the same side length, which means yes. Are these identical? 4, 6, 8, and 4, 6, 8. So yes. They're all 4, 6, and 8. So there is only one unique triangle. It's the angles that can be like different triangles with angles. So like this one, they didn't give us side lengths. So they have the same angles, but they still are not identical. These ones, once again, we have all the same angles, but they're not identical because they have different side lengths. Many different triangles. So angles can be different, but when you have the same side lengths, you're looking at one unique triangle. It's like this one, there's 4 and 6 and then 30 in between. Over here, the 6 would have to be on the long side for it to be identical. Okay, and here we have same thing, that 6 would need to be on the longest side for it to match the orange one. So with this one, 6 is not on the longest side every time. So there are many different triangles. And then we're on the last little block of this. So you have 40 and 30, and then 6 on the top. But they are still not identical. Now with this one, we could turn it, turn it, turn it, turn it, turn it. One more time, slide it over. There you go. So these ones would be. So the key word here, what they said in the video, is there can be many different triangles because you're putting them in a different order. Now, if they went in the same order every time, they would be identical every time. But depending on where you put that side length, changes that triangle.